Welcome to the video lecture for section 2.3. This is for MGF 1106 Liberal Arts Math, and my name is Jorge Gavillan. So in section 2.3, we have the following objectives. The first one is going to perform set operations of union, intersection, complement, and difference. We're also going to be able to perform set operations in proper order. We're also going to be able to apply De Morgan's law and set theory. We're going to use the inclusion-exclusion principle to calculate the cardinal number of the union of two sets. And then finally, we're going to use Venn diagrams to prove or disprove set theory statements. So the first thing we're going to talk about is the union of two sets. So the union of set A and B, and here's the symbol that we write it as. We have capital A. Remember, capital letters will always denote sets. So we have capital A, U, and then B is the symbol that we use to denote the union of A and B, or the union of two sets. Now this is the set of elements that are members of either A or B or both. Now the one thing about OR in mathematics is that OR is inclusive. So when we talk about OR, we mean that it's everything that's in A and B at the same time. So just give you a quick example. If we were speaking of everyday language and I would say, well, either Peter or John will go, that means that if Peter goes, John doesn't go, and if John goes, Peter doesn't go. In mathematics, it means they're both going. So in set builder notation, the union of A and B is equal to the set of X, such that X is a member of A or X is a member of B. So the union of more than two sets is the set of all the elements belonging to at least one of the sets. Now, so you can see here in the diagram that the elements in A and B is everything that's in A, everything that's in B, everything that's in both of them. So here we have an example. We're going to find a union of the following pair of sets. So we have A is the set that contains the numbers 1, 3, 5, 6, and 8. B is the set that contains 2, 3, 6, 7, and 9. So the union of these two sets, as you can see, is actually 1, 2, 3, 5, 6, 7, 8, 9. So notice in the final answer how we listed the elements in order and did not list duplicate elements, because doing so does not affect set equality or the cardinal number of sets. Now the intersection of sets, A and B, and here's a symbol. So here we have like an upside down U to denote the intersection of two sets. It's a set of elements that are both common to A and B. So in set builder notation, the intersection of A and B is the known numbers X, such that X is a member of A and X is a member of B. So the intersection of more than two sets is a set of elements that belong to each of the sets. Now, if the intersection of sets A and B is the empty set, then we say that the two sets are disjoint. And here you can see in the diagram that the intersection of the two sets is simply what's common to both of them. And in this case, is region 3. So here's another example. We're going to find the intersection of the following sets. So we have set A again has 1, 3, 5, 6, and 8. Set B, 2, 3, 6, 7, and 9. And then the intersection of the two sets are simply 3 and 6. 3 and 6 are in A, and 3 and 6 is also, they also belong to B. Set complement. If A is a subset of the universal set U, the complement of A is a set of elements of U that are not elements of A. This set is denoted by A prime. So in set builder notation, A prime is equal to X, such that X is an element of U, but X is not an element of A. And you can see here in the diagram that the complement of A is everything that's in the universal set but not part of A. So finding the complement of sets. Find the complement of each set. We have stated a universal set for each set. So universal set of numbers 1 through 10. Set A contains 1, 3, 5, 7, and 9. So universal set of the set of people living in the United States, or sorry, part B. U is a set of people living in the United States, and I is a set of people who have photos on Instagram. And for C, U is a set of cards in a standard 52 card deck, and F is a set of face cards. So for A, we can see that A prime is a set of elements that are in U but not in A. So A prime then contains 2, 4, 6, 8, and 10. And then for B, U is a set of people living in the United States. I is a set of people who have photos on Instagram. So then I prime is a set of people living in the United States who do not have photos on Instagram. And then for C, U is a set of cards in a 52 card deck. F is a set of face cards. So F prime is a set of non-face cards. Difference or set difference. The difference of set A, B, and A is a set of elements that are in B but not in A. This set is denoted by B minus A, or the difference of A and B. And set builder notation, difference of sets B and A, it's X such that X is a member of B and X is not a member of A. And you can see the diagram here that the difference of two sets, it's simply what's in B but not in A. Now, if an element belongs to A and B, we have to exclude those. So finding the difference of sets. So find the difference. So here we have the set. The first set contains 3, 6, 9, and 12. The second set, x is an odd integer. So we start with 3, 6, 9, 12. Remove all of the odd integers, and we get 6, 12. Now, order of set operations. Just as we must perform operations in a certain order, set notation specifies that the order in which perform set operations. So here's an example. Here we have the noted sets U, E, B, and A. So we're going to go ahead and find the complement of the union of A and B and the intersection of the complement of E, then of the E complement and the union of A. So the first thing that we're going to find is we're going to find the union of A and B. Then we're going to go ahead and find the complement. Then we're going to find the complement of E. Then we're going to find the union of the complement of E and A. And then finally, we're going to go ahead and wrap it up. And so you can see that A union B, so everything that's in A and B, so 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 7, and 8. The complement of that is 6, 9, 10. Now E, x is an even number, so then E prime will have odd numbers, which is 1, 3, 5, 7, and 9. Now the union of that set in A would be everything that's in the complement of E, or E complement, in A, which is 1, 2, 3, 4, 5, 7, 8, and 9. And then to finalize it, we find number 2, which is 6, 9, and 10, and the intersection of number 4, so you can see how they order 1, 2, 3, 4, 5, and then the intersection of that is simply the set that contains the number 9. So order of set operations. The Morgan's law for set theory. If A and B are sets, then A union B complement is equal to the complement of A and is equal to the intersection of A prime and B prime. And also, the complement of the intersection of A and B is equal to A prime union B prime. Now, the inclusion-exclusion principle. If A and B are sets, then the cardinal number of the union of A and B is equal to the cardinal number of A plus the cardinal number of B minus the cardinal number of A and B. Now, for those of you who have taken stats, this should look familiar. This is a formula that we learned in probability. So the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. And that's the end of section 2.3. Thank you.